Hello and welcome to a global event hosted by Kingspan. At Kingspan, we like to stay curious and ask ourselves, what if? What if you could have an A2 insulation material that didn't compromise on thermal performance? And what if, therefore, that insulation could be slimmer than traditional alternatives? Today's masterclass will look at AlphaCore, our A2 insulation board for rain screen facades. We understand that you might be curious too, and you might have some questions. And if you do have any questions, please do send them through to our email address, and we'll be happy to answer them after the presentation is finished. And if we don't get round to answering all the questions, we'll email you after today. And now I'll hand over to Tobias to present to you.
Thank you very much, Lucy. So, yes, what if A2 insulation board could be slimmer than traditional products? I'm trying to shed a little bit of light onto that topic, introducing AlphaCore, a new product that we launched in the Kingspan world, and that tried to give an answer to that question. But before I come to that, I have to actually travel a little bit back in time, because approximately 1 year ago, Kingspan had the opportunity to acquire the Karlstad product and technology from the German-based chemical manufacturer Evonik, and they introduced this product into the market, which is a mineral-based, microporous, high-performance insulation product. So we embraced this opportunity, took it on board, and we now coming onto the market with a rebranding of this product, and we call it AlphaCore. It's a high-performance thermal insulation, as I mentioned. It's mineral-based. It has an A2 as 1D0 rating and classic reaction to fire, and it enables the architects to come up with thin solutions, with slimmer facades, slimmer build-ups, and face the challenges that we face in the today's world of building insulation. Right. Perhaps before I dive into the topic, a little fun fact, because we speak of high temperature insulation. If you have a stove like this in your house, for example, you have these spirals here, glowing red, producing a lot of heat and warming up your food, which is quite good and well, but at the same time you have to protect the electrical wiring underneath these heating fields from getting damaged. And this is done not with AlphaCore as such, but a product made out of the same raw material, but in a slightly different composition. And that already gives you an indication what this product is capable of, and how it can perform in high temperature environments. Which brings us to the product properties itself. I touched upon it already. It has a reaction to fire A2 as 1D0 classification, but we have to look at this also a little bit closer. What does that mean? And I'm going to touch upon that one in a slide later on. It is a high-performance thermal insulation product with a lambda of 0.02. There is actually a definition for super insulation materials in the sense of what kind of value they have to achieve. And we tick these boxes with this product. Another outstanding characteristic of this product is that it is completely water repellent. So what we do is we produce the board and we afterwards hydrophobically treat it so that it doesn't take up any moisture. But I'm also going to dive a little bit deeper into that one later on. Yes, it has a very good thermal performance, and therefore we can achieve slimmer build-ups. So this product is mainly used where space is very, very limited, and non-combustibility or A rating is of importance in the building envelope. And if we compare it, for example, to the K-Rock rain screen slab, we can realize up to 40% slimmer build-ups, which create more space internally of the building. Right. It is a very technical product, and that's why I would like to go a little bit more into detail. How does it and why does it perform that well in that context? And this is actually a picture if you would take a very, very close look at the product. So we have these primary particles, which are little bubbles, mineral-based bubbles. It's silica, it's sand at the end of the day. So what we do is we take this sand apart in very, very fine particles, and it is then bonded to these longer chains of product through a thermal process. So what we have is then this raw material that we compress to a board, and there are three mechanisms of heat transportation that we try and counter with this product. The first one being conductivity, so through the product itself. First of all, the particles are very, very fine and very, very small, so the transport is already limited. But on top of that, in these chains, these products only touch each other in a very small spot, and that limits the transport of the heat through the material itself. The second one, convection, that we counter by having a very, very small porosity. So yes, there is air within the board, but the air can't resonate that well with heat and can't transfer it that well. So that's why the heat transfer through convection is very, very limited. The third one, being radiation, is something that we counter by adding an opacifier to the product. The initial particle is white as the sheet in the background, but now we add an opacifier that makes the product appear gray, which absorbs infrared radiation and reduces the heat transfer through that mechanism as well. So it is kind of technical, but it's very important, I think, to understand this product. So this is a topic, again, this is what would happen if you pour water onto the product. As I mentioned, it's hydrophobically treated, so it's completely water repellent. So if you take the board and drown it in water and take it out, it will rinse off. It will be completely dry. If you cut the board and drown it in water as well, even there where you cut it, it will not take up any moisture, so it's hydrophobically treated to the core. However, the product is vapor open. So vapor can travel through the board. It's actually, with a mu value of 5, it's pretty open. So what you would ask the question then, obviously, what happens if vapor travels through the board and reaches the dew point? Does it then accumulate moisture? The short answer is no, because we speak of a microporous product, and the porosity is so small that a water droplet cannot form within AlphaCore. So it will always stay dry and will maintain its thermal performance all the time. This is now quite a busy graph as well, but in this graph I speak about the fire performance of the product, and since it performs extremely well in that sense, I think it's worthwhile going a little bit more into detail on that one as well. So this is a graph and data we took over from Evonik at the time. That's why you find the ColorStat name here. And what we do in this whole setup is we try and simulate a fire and see how the product reacts to that. So we have, first of all, the timeline here, which is in minutes. So you can perhaps stop here at 180 minutes, which is the equivalent of 3 hours, obviously. And then you have here the temperature line in Kelvin. So this is a little bit odd because Kelvin starts at the 0 point of Kelvin is minus 270 degrees Celsius. So if you add that and come to 293, that's basically equivalent of room temperature. So what we do in this test is usually a whole system buildup is penetrated with a fire on the one side, and then you measure the temperature rise on the other side of the product. So it starts at 300-400 degrees Celsius approximately and gradually builds up to 1100 degrees. That being said, we look now at the 40 millimeter product. We start at room temperature, exposure of a flame on the one side. It takes a little bit of time to go through the board, and then it gradually builds up. So after 3 hours, where do we stand? actually a temperature increase of approximately 110 degrees Celsius after 3 hours. That is extremely good for an insulation product. And that is why some people look at this product as a non-combustible insulation material, and others look at it rather as a fire protection board that can insulate very well at the same time. And that's basically what it boils down to. And this is, in my mind, the reason why I have to go a little bit more into detail, because it's not just A-rated, it performs extremely well. Right. This is the performance matrix, where we see this product in the bigger picture of most of the products that are available in the today's building environment. So clearly you see we position ourselves with this product in the A-rated area, and obviously below an equivalent and below the lambda value of 0.02, which is the super insulation materials, and there where we see ourselves. So this product, yes, is mainly used where space is extremely limited, and A rating is of importance for the performance. And then we come to the variants that we offer to the market. First of all, the AlphaCore pure material. This is a compressed powder without any organic binders that would ruin the fire rating performance or the fire. And it comes in sizes of 1,000 by 600, thicknesses starting from 20 to 50 millimeters, A-rated, thermal conductivity. However, this product is a little bit sensitive, it's a little bit brittle, one can say, and therefore we suggest to use this product in prefabricated constructions, like unitized facade elements, for example, that are created and assembled in a protected environment and then installed on site. The second product we have is the AlphaCore pad. Same dimensions, same performance. The difference is we wrap this product basically in a glass fiber fabric, which makes it better handleable on site. So this is then for the on-site application for rain screen facades, for example. And you can cut it and trim it on site the way you want it. You can close the cut edges off with a tape that we provide as well. And it just has better handling properties for an on-site application. And there we are already. We promote this mainly in high-rise facades, and especially in new builds, for example, in highly densely populated areas, high-rise buildings, city centers like London, for example, where you try to reduce the build-up as much as possible in order to increase floor area that you can sell to the market at a higher price than what you pay for the insulation. And that allows the architect also to come up with slimmer facades. They can play more on the designs they want to implement. And we also see this product not only in new build, but also very much in the refurbishment market, because often you have limited space available if you want to increase the thermal performance. If you go with more traditional products that are also A-rated, you end up having thicker build-ups that might go over the building line. Then you have to negotiate with a city council on how to go about it. And this might give you the opportunity to stay within the building limits and achieve the required thermal performance that you. But also, if you have a space available that is not enough to solve with a more traditional approach, like for example a mineral fiber, but you have space left after implementing AlphaCore, for example, we are also very open to use that in a hybrid solution in order and combine products in order to find the sweet spot between performance and cost. And this is where this product could also add quite a good value to the building envelope. And then what does that mean in reality? We have to try and explain it a little bit in order what kind of space we can save by using that. And we did that just as a quick reference guide with some typical U values, comparing the thinnest solution possible with AlphaCore versus the K-Rock rain screen slab. And we used here a certain standard SFS built up, so that we compare apples with apples. So, and how does it work out? So we have, in both scenarios, we have a 100 millimeter K-Rock framing slab in there in the SFS system, and then the sheathing board, and then the installation that goes on the outside. And now we look at basically a U value of 0.19 that would require 70 millimeter of pad on the outside on top of what's existing there already. Alternatively, if you would go with K-Rock rain screen slab, you would need 110 millimeters on top of that. So here you already see the distance and the difference, what it brings to the table. The more we go down with the U value, the higher the discrepancy. You can see with the U value of 0.11, we still speak of 150 millimeter of AlphaCore, but 240 millimeter of K-Rock rain screen slab. Now, if you add that up by the stories of the building and the length of the facade, that adds up to quite some space internally that, for example, in London is much, much more valuable than the investment in the higher priced product. So in that sense, very interesting tool for the architect to play around with and to come up with solutions that fit the time and requirements and challenges that we are facing right now. Right. Other applications. We've done that one here also still at times when the product was with Evonik. That's a construction site in London where we used AlphaCore in the soffit basically. And there may be in soffits and car park height restrictions with head clearance. In this case, we also had the requirements, first of all, of non-combustibility, but secondly, there were ducting and cable trays that ran through the ceiling and through the basement that were planned at a certain height, and there were just simply height restrictions. And you can see that here the mechanical fixing is not 100% to the standard. Why is that? Because it was in 2 layers. And we pinned the first layer with just 1 pin to the ceiling to keep it in place, the second layer with 2 pins also to keep it in place, and then we had a 6 millimeter fiber cement board with the right amount of fixings per square meter to have everything safe and sound in the basement. But this is something we do with this product, and that's where it has been used quite extensively. This was a project, for example, for 6,500 square meters altogether. Right. Future developments, they have not been launched yet, but we are working on them for different applications, basically. And handability on construction site. This is the Sandwich MW. So we combine here an AlphaCore product with other materials. In this case, a high-density mineral wool layer in 10 millimeters, and we combine it on both sides and we stitch it together with a thread. Like this, we have a very solid and robust board that can be used, for example, with a render system, or could be used with a render system, and that works quite well. It can be also used and installed on a construction site, and it can be cut and trimmed very well and installed there. However, we have a core material which is performing very well thermally, and then we have 2 other layers that don't perform that well. So the overall lambda value of the board is really depending a little bit on the thickness and the proportion of the materials used. And then we are working and thinking of something else, which is the Sandwich MWF. This is basically the same build-up as the previous product, but in that case, we eliminated one layer of mineral wool, and we used a fleece there in order to minimize the less performant mineral wool in this whole build-up, which results and will result in a slightly better overall thermal performance of the whole board. And that could then also be used with a render system, for example, but also in rain screen facades, and that's what we're aiming for. Yeah, I don't know whether I was okay in time, but I thank you very much. And what I would like to really point out is, please, if you have any questions, punch them in your email in with this email address, and I'll gladly answer everything you would like to ask. Yeah.
Thanks, Tobias. We have had some questions come through online, so we will take some time now to answer them. So one that we've had come through while you were speaking is, how does the AlphaCore Pure AMPAD perform in relation to sound transmission?
To sound transmission, very good question. There are basically two types of sound. It's the sound in the construction itself and the sound absorption property of the product. The thing is, it improves the sound performance to a certain degree, but it's not the strong point of this kind of product. So you wouldn't use AlphaCore because of its sound improving or sound performance in that sense. But it doesn't worsen the construction. So it improves it a little bit, yes.
And I would imagine that's why sometimes we would offer a hybrid option as well, because you can combine multiple material attributes.
Absolutely, yeah. And it has been done in the past, especially in unitized facade elements, where you sometimes then add an adequate layer that improves the certain performance requirement that you are facing. Yes, you can do that.
Okay, thank you. And where is the product available?
Yeah, the product has been launched in the UK and Ireland. It's readily available there. We are launching it basically, or introducing it to the market next week in Germany on the ZAC World of Facade Conference in Frankfurt. And then it's going to be available in the Central Europe region. And we're going to then next year also going to introduce it into different other markets within mainland Europe.
Watch this space, I guess.
Absolutely, absolutely. I mean, if you have project inquiries, obviously the certification, the European Technical Assessment document is in place, so it can be used, within Europe, and so yes, we can support you there. If you have any questions, project related, obviously, kindly inform us. We will gladly support you with everything you need.
Okay, thank you. And final question, are there any other applications where the product can be used?
Yes, very good question, yeah. Even though we're now focusing a little bit on rain screen facades and unitized facades, it can obviously, in soffits, as I showed, it can also be used as an interior wall insulation and also in roofing applications, but we haven't explicitly launched it for those applications yet. But in case something comes up, we can gladly support you in that sense as well. But it is also an area where this could be used.
Okay. Thank you. And thank you, Tobias, and thank you to everybody watching at home. I hope you enjoyed the presentation, and as Tobias has said, if you have any further questions, we'd be happy to help, so please do send them in. Thank you.
Brilliant. Thank you very much. Thank you.